I watch a lot of YouTube. I saw AVE make fancy grill plates out of blocks of aluminum on his Tormach CNC machine. And speaking of Tormachs, I see Shane from Stuff Made Here building explosive baseball bats on his. And then this morning in my YouTube recommendations, I saw Jerry Rig Everything building a custom electric Hummer with 12,000 pound-foot of torque. Meanwhile, I'm more of a software guy holding a Raspberry Pi Zero in my hand, tripping over this tripod in my tiny office. I'm thinking, what kind of things could I do if I had access to the knowledge and machine tools those makers have? Well, I figured I should start somewhere. If Jeremy Fielding can build a 7-axis robot arm using a CNC mill and some other machine tools, I could build some sort of contraption to help me get rid of the tripod so I could get a little more room in my office. So I bought this cheap TV ceiling mount and figured I could find a way to mount my camera rig onto it. If it's good enough for a 66-pound TV, it should surely be good enough for 5 pounds of camera and a teleprompter. The first step was getting the ceiling mount installed. Unfortunately, in my office there aren't any joists near where I wanted to mount, so I had to put up this board to span the joists. If I had ever planned on making YouTube videos in this office when I built it, there would be a lot of things I'd have changed. I wanted to build a sturdy bracket to hold the camera, and I toyed with the idea of using my 3D printer for it, but I just couldn't trust a $1,000 camera setup on top of a printed block of plastic. So I looked into sheet metal. I have hand tools for working with thin sheet metal, but I've never worked with sheet metal thick enough for this project, so I put a pin in that thought process and focused on the bracket's dimensions. I took a sheet of paper and folded it, then I made a few marks on it to try to see where I thought the mounting plate would go to support the camera at the right height and angle. Then I traced the holes from the VESA mount plate that came with the ceiling mount onto the sheet of paper and measured everything precisely so I could build a model of it on the computer. I knew that no matter how I made my bracket, if I wanted to get it cut out with water, a laser, or some sort of CNC machining, I had to turn my paper template into a computer model. I had used Fusion 360 in the past, but I didn't like two things about it. First, it's not open source, and it's kinda sorta free for makers, for now at least, but Autodesk seems to be like Adobe, and that doesn't make me super happy using it. Second, the UI always feels buggy and sluggish no matter what computer I used, and I don't think I've ever gone for more than an hour using it without it crashing on me. So I tried building a new model from scratch in OpenSCAD, which takes an entirely different approach to 3D design. Instead of using a GUI to design, you basically script your 3D model. And as a software developer, I really like that approach. But I also had to dust off some old algebra and geometry to try to get all my coordinates right. After an hour or so, I had a model for the plate that was the exact dimension I had measured. I opened the final model in Mesh Mixer to bend the end of it. And now I had a 3D model of the flat plate for a cutting pass and a model of the final dimension so I could test out how it worked once it was bent into shape. The nice thing about having a 3D printer is I could quickly print off a part with the exact final dimensions for a fit check even if I wouldn't put any weight on it, and so I printed it. I dry fit this printed model, and when I put it together, everything looked great. Doing this gave me the confidence I was on the right track, so the next steps were figuring out how to get the sheet metal cut and bent precisely. I figured I might be able to MacGyver my way into cutting the shape with tools I have, but I knew I wouldn't be able to fold the metal at a 90-degree angle without the right tool, so I started looking into buying a proper metal bending brake. Sometimes I budget in a new tool when I do a project like this, but only if I can justify the price and know I'll use it in the future. That's how I got almost every tool in this workshop over the past 20 years. And now Redshirt Jeff freeloads in here like he owns the place. But the brake I'd need for 3mm steel or aluminum costs thousands of dollars, and yeah, I just can't justify that. So I started asking around on Twitter if anyone knew a good place where I could get this thing fabricated, ideally in my hometown of St. Louis, and Sam Ronsky linked me to Made STL. Apparently, there's a great Makerspace right here in my hometown about 15 minutes away, and I'd never even heard of it. The idea is that for people like me who have big ideas but don't have the space or budget for the tools to build them, we pool resources together into one central place. And in the case of Made, it's even better because they were able to resurrect equipment and some of the community from Tech Shop after they shut down nationwide in 2017. Made has some very fancy tools, like a $100,000 waterjet that can cut through 6 inches of steel plate, but you only have to pay a small fee to be a member and use it. And I wanted to use that waterjet. But after taking a tour with Emily at Made, I realized I'd have to get a training to learn how to safely operate the machine and become a member before I could start using it to build my bracket. I wanted to get this thing done soon since I try to continuously improve my recording setup, so I didn't have time to do all that, at least not yet. So I found out there's a service called Custom Made where I could send over my 3D file and the idea, and someone at Made would actually build the thing for me. So I talked to a guy named Tim about my project, and he graciously allowed me to film the process of him cutting my plate on the waterjet, bending it on an industrial-sized brake, and grinding it for a clean finish. I can't describe how it feels the first time you see something you thought up and designed from scratch being cut out precisely down to the millimeter with a huge industrial machine I've only ever seen in episodes of How It's Made. I grabbed my tap and die set and tapped a 1/4x20 hole for the tripod screw, then grabbed one of my tripod screws and put it in the mount. I installed the bracket on the mount and put my camera on it, and it's solid. And because I have the arcs for the screw holes here, I can adjust the tilt of the camera and lock it down once I have everything set up exactly where I want it. Are there things I'd do differently if I tried doing this project again? Probably. Could I have just bought a magic clamp and a magic arm and mounted the camera to the pole that way? Maybe, but it would have cost more and I wouldn't have learned OpenSCAD or even found out about Made. And could I have just mounted the camera to a pole on my desk instead of the ceiling? Sure, but then every time I type or touch my desk, the camera would wobble since my desk isn't really that stable. In the end, the lesson I learned is that I don't have to have a huge workshop full of expensive tools and tons of experience to make the things I want to make. I just need the money to pay someone else to make it for me. No, but really, the more important lesson is that I'm realizing if I can dream up something, chances are I can build it. That's a powerful thought these days when we see so much of the stuff in our lives being made in other places and so few people getting into manufacturing and other blue-collar jobs these days. Maybe it's time for us all to learn a bit more about building our own things. Maybe I can inspire you to take some idea you had kicking around in the back of your mind and start making it real. I never thought I'd be making YouTube videos about how I made things to make YouTube videos more easily, but here I am. I dreamt it and I'm doing it. And maybe you could too. And if you're in St. Louis, maybe I'll see you at Made someday. Until next time, I'm Jeff Geerling. Oops. Cut out with a water, with a laser, with a water. Ah, crud. When you say that on YouTube, you get more clicks, so there you go.